so this is going to be this is our last method to prove that a quadrilateral is a parallelogram. And the last method uses both the slope and the distance formula. So if you remember, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. And it doesn't matter which pair of opposite sides, right? But if one pair of opposite sides is both parallel and congruent, the quadrilateral must be a parallelogram. So this is our fourth and final way to prove a quadrilateral is a parallelogram. All right, and this one is in your notes, and it should already be graphed for you. So step one is done. There's the graph. So now step two, we're going to, and I already wrote it in for us, so step two is literally written in. We're going to show ABCD as a parallelogram using the slope and the distance formulas. I'm going to add a little bit to that. We're going to prove one pair of opposite sides is both parallel and congruent. All right, there, that is a good show. What do we want to show? Because that ensures we're going to use the formulas that we need, and we're not going to do more than we need. Right? So we're only going to use the slope formula to prove a pair of sides is parallel. We're going to use the distance formula to prove a pair of sides is congruent. And we do not need to find the slopes of all four sides and the length of all four sides because we wrote down one pair, right? So, and it doesn't matter which one, we'll pick a pair, right? But the formulas that we need is the slope formula, change in x over, change in y over change in x, and the distance formula. Which is the square root of the change in the x value squared plus the change in the y values squared. All right. How about we'll use these two sides. All right, we get the same thing if we use the other pair of sides. But let's use those ones. All right, so we are going to now show our work. All right, so we're going to find the slope of BC. All right, so that will be, so we take the difference in the y coordinates, so 1 minus 2 divided by negative 3 minus 1. And 1 minus 2 is negative 1. And negative 3 minus 1 is negative 4. Those negatives cancel, and so that is 1/4. Now let's find the slope of AD. All right, so we got negative 2 minus a negative 1 divided by negative 1 minus 3. So that's the same as negative 2 plus 1. So negative 2 plus 1 would be negative 1. And negative 3, let me write, actually, I don't know if that's that easy to see. Negative 1 minus 3 is negative 4, and so the negatives cancel 1/4. So you see we got the same slope for both of those. Now let's find the distance. Let's find the length of them. So BC, difference in the x coordinates, so that would be negative 3 minus 1 squared plus 1 minus, difference in the y coordinates, 1 minus 2 squared. Negative 3 minus 1 is negative 4 squared, and the whole thing is squared. It's going to be positive. Distance is always positive. Plus 1 minus 2 is negative 1 squared. So negative 4 squared is 16. Negative 1 squared is 1, so that's the square root of 17. And no, it does not simplify. That is a prime number. Now let's find the length of AD. Right, so difference in the x-coordinates, -1 minus 3 squared plus -2 minus a -1 squared. -1 minus 3 is -4. -2 plus 1 is -1. And I think you can see that that's going to be, again, 16 plus 1, which is going to be the square root of 17. All right, so that's all the work we need to do, because we don't care about the other two sides. All right, could I have used AB and CD? Absolutely. All right, we could switch and use those. Do we need to do all four sides? Absolutely not. That's overkill. That's much more than we need. We're using one pair of opposite sides. All right, so I'm going to do a paragraph proof again. Let's see if I can make my sentences not too long. I'm going to start with the formula. Using the slope formula, BC is parallel to, where's my shadows blocking, AD. And I'm just going to put what the slopes are. Both have a slope of 1/4. Using the distance formula, BC is congruent to AD. Both have a length of a square root of 17. I'm going to use a symbol for therefore. Therefore, okay, so this comes directly from what we just found, right? Therefore, ABCD is a parallelogram because, and we have to say why, it has one pair of opposite sides that are both, and it's fine to put symbols in, that's easily understood as that is universally understood as parallel, and this is universally understood as congruent. So, using the slope formula, BC is parallel to AD. Both have a slope of 1/4. Using the distance formula, BC is congruent to AD. Both have a length of square root of 17. Therefore, ABCD, what happened to my therefore? There we go. That's therefore. Therefore, ABCD is a parallelogram because it has one pair of opposite sides that are both parallel and congruent. And there we go. Look at that. We did everything in less than 9 minutes while I was talking the whole way. All right, so now you can do the parallelogram proofs. I will write down on Schoology which ones you can do from the homework. And then we're going to do the same thing with the next group of proofs, which is rectangle. All right, bye for now. Thanks for watching.